Hello everyone, here I am presenting to you on how to get the thrust coefficient using blade element momentum theory by utilizing the Labview software. Opening the Labview software, you will be prompted by two panels, the front panel, where the user of the program input the numerical variables needed, and the block diagram panel, is where the graphical source code are contained to create a program. Here is the preview of the block diagram panel. In this program, we will utilize the thrust coefficient formula shown here below your screen to convert it to graphical source code in the block diagram panel so that the user can estimate the thrust coefficient using the front panel without doing some manual calculation. In order to solve the thrust coefficient, first, the user will input in what section of the propeller he wants to get the value of the thrust coefficient. Let's say, for example, I will get the portion of propeller between 33% and 66% of the propeller section. So take note, the propeller section must be in percentage. So we'll put here in 33 and 66. In the block diagram panel, your inputs will be coded here in the numeric controller, and using some formula to get the average, the Labview will try to calculate your input to show it in the average. This average numeric indicator will also be shown as the results in the front panel. After determining in which section you want to solve the thrust coefficient, you need to determine what is the advance ratio of your propeller blade. Here, you can choose either to input the forward speed and rotational speed or directly to the advance ratio. So in the block diagram panel, it is shown here in a conditional code. So if I use true, it means that I will calculate the advance ratio directly. But if I will choose the forward speed and the rotational speed, so means the conditional code will be changed to false. This means your input in forward speed and rotational speed, the Labview will try to calculate this formula. But in this case, we will use the advance ratio, 0.6. Since the switch is in false condition, we will try to switch it. So this means that Labview will try to calculate this formula. Next, we will try to input some variables needed, especially here in expression node C, which this means is the solidity of the propeller blade. So there are three variables needed: the number of blades, chord of blade section, and radius of propeller. So in the front panel, we will try to input the number of blades. Let's say, for example, we have 3 blades. The chord of the blade section, this means that the chord of that propeller blade section, we just input here between 33 and 66%. Let's say, for example, the chord of the blade section there is about 0.42 inches. And take note that the input variables must be in similar units in case of in length. So this means in the radius of propeller must be also in inches. Let's say the radius of our propeller is 3 inches. So it will now try to calculate the solidity. Then, after a series of calculation of formula, we have here called the induced angle. It can be also shown in the front panel as the induced angle. And induced angle formula is a very long formula which it needs solidity and the formula. And in this case, we group it into expression nodes so we can be easily determine the calculation of the formula. So there are inputs needed like the section of the leaf curve slope. So the user will input here, let's say for example 5.7. That's our section of leaf curve slope. And the pitch angle, say the pitch angle of your propeller is in 33 degrees. So after we completed all the inputs, the induced angle can be readily computed. And take note, in solving the coefficient of lift, we need the induced angle. So if the induced angle is already computed, CL can be computed as well as CD. But there are conditions in computing CD. Let's take for example, this is true, which means if your CL is less than or equal to 0.15, the value of your coefficient of drag will be 0.01. But if this statement is false, if, if the CL is greater than 0.15, the Labview will calculate this formula in order to get the result of your coefficient of drag. So after getting the CL and CD, we can now compute the coefficient of thrust. Going back to our front panel, we are completed all the inputs needed in order to show the result of our average of the section of the propeller, the induced angle of that section of the propeller, the effective angle, coefficient of drag, coefficient of lift, coefficient of thrust, as well as the coefficient of power. So we need to do is to click OK, and then you can see the results. So, okay, that's the end of the presentation for computing the coefficient of thrust. Thank you.